After studying this module, you shall be able to get a preliminary understanding of regression analysis, understand the applications and assumptions for regression analysis, and use SPSS 20 for regression analysis. Introduction. Suppose in a group of 40 applicants in an organization, one wants to estimate the number of employees who would be efficient in working on a particular project, knowing their past academic records. The best possible guess that can be made is that since the job requires an average academic performance, an average scorer could be the best possible choice. So, in that group of 40 applicants, one would take the mean percentage academic performance, and those applicants who lie in this range can be predicted to perform well on this job. One can understand that if any two variables are related to each other statistically, that is, if they share a fair degree of covariance or have a high positive or negative correlation, then a measure on one variable can be used to predict about the possible score on the other variable with fair amount of success. Like, a researcher may know that intelligence score is highly positively correlated with academic achievement through the data collected on a sample. Using this information and the concept of regression, if the researcher has a measure of only one of the variables, intelligence or academic achievement, then one can make predictions about the other variable with a fair amount of accuracy. So, the concept of regression analysis is a step forward in the direction of studying relationships among the variables statistically and using it to the advantage of predicting the others. Regression analysis. What is regression analysis? Regression analysis is a method for predicting the specific value of one variable when we know or assume the value of the other variable. This was by Cohen and Holliday in 1996. It is a way of modeling the relationship between the variables. The predictor or the regressor or the independent variable, as we call it, is the term used for those variables that may be useful in predicting the scores on another variable that we shall call the criterion or the outcome or the target or the dependent variable. As we have studied in the previous module, the simple regression, there is only one regressor or independent variable that is used to make predictions about the criterion. The complex designs in psychological research have multiple independent variables, and therefore, when all or some of these independent variables are used to make predictions about the criterion, then one refers to it as the complex or multiple regression. To predict any data or outcome, one can fit whatever model that is being followed and add some amount of error. In simple regression, the model followed is linear, which summarizes a data with a straight line. We shall explore the concept of multiple regression in the next module. The present discussion focuses on how the regression models are developed and applied to the set of data. The regression analysis includes a number of techniques to develop models for analyzing a set of variables. The focus of these models can be two or more than two variables. The basic idea in regression analysis is to understand how the typical values of the dependent variable undergo change when one or more of the independent variables vary, while some of the variables may be held constant. The target analysis is to arrive at a regression function that characterizes the change in the dependent variable around the regression function, which can be described with the help of a probability distribution. Utility of regression analysis. The concept of regression analysis has wide and popular usage in the field of quantitative statistical analysis of the data. Some of them are: it is widely used for predicting and forecasting. It helps in exploring the relationships between the dependent and the independent variables, and with multiple independent variables, this exploring of relationships is all the more important as one is able to identify the important predictors from the set of variables. The regression analysis can be used to infer and understand the causal relationships among the variables. Although this may lead to elusive results, but a careful understanding may give us useful insights in data analysis. The concept of regression analysis. The focus. The focus of analysis in regression analysis is to analyze the extent that an independent variable is related to the dependent variable. To predict or forecast when the value of one variable is known, but the value of the associated variable is unknown, and to quantify the strength of relationship between the variables, and to take the decision about the dependent or independent variables when the relationship between the two is known to be high. The variables in regression analysis. In simple regression analysis, there is a continuously scaled independent variable referred to as the predictor. The dependent variable is also continuously scaled in interval or ratio level of measurement. The relationship of participants' scores across the group. For regression analysis, the scores are dependent on each other for all variables being used. And the underlying assumptions for regression analysis in brief are that the regression analysis should address assumptions like homoscedasticity, linearity, normality and independence of errors. Let us explore and understand these assumptions in detail. The assumptions for regression analysis. The statistical technique of regression analysis has wide and popular applications in the field of quantitative statistical analysis. Upon taking care of certain assumptions, the accuracy of regression analysis depends upon the fulfillment of these assumptions. However, it has been observed that minor violations in the assumptions may not cause much errors in the results. The researchers should be careful about major violations in the assumptions, as they may result in undesirable flaws in predictions. Some of the assumptions that need to be met by the data before its exposure to the linear or multiple regression analysis are: linearity in relationship. The relationship between the variables should be linear. This simply means that relationship between the two variables being considered for simple regression can be described using a straight line. This assumption can be easily checked by drawing a scatter plot, and it is imperative that the data is checked for outliers, as they have a detrimental impact on the quality of results. If the outliers are present, then suitable corrective measures should be employed. We must either delete those outliers or take care of them so that they do not interfere too much with the results. Normality. Whenever a researcher wishes to use the regression line for the purpose of prediction, it should be made sure that the distributions for the variables x and y are normal. If the distributions deviate from normality, then the skewness should not be very high. The assumption of normality in a bivariate distribution can be checked using the graphical method of histogram. Multinormality. When complex regression analysis need to be taken up, the assumption of normality proves insufficient and multi-normality needs to be checked. All the variables chosen to be part of the regression model need to be multinormal. A set of k variables is said to have a multivariate normal distribution if given any set of values of k minus 1 of them, the remaining variables are normally distributed. Multinormality is an assumption which is imperative to multivariate techniques and therefore a must in multiple regression analysis. Multinormality can be tested using QQ plot and relevant transformations like log linear transformations can be used for correcting the multinormality absence in the data. But it must be taken care of that the assumption of multinormality is imperative. Homoscedasticity is the other assumption that needs to be met. The homoscedasticity refers to the uniform spread or scatter of scores throughout a distribution. It is assumed that the estimated or the predicted values are scattered uniformly around the observed values for all the observed scores of the distribution. This enables the researcher to use a uniform or same measure of spread, that is standard error of the estimated variable. To put in other words, one may assume that the range of permissible fluctuations in the predicted values of the variable are same for all the observed values. The other assumption is of multicollinearity. The multicollinearity occurs when the variables share high degree of covariance among themselves. For accurate regression analysis, multicollinearity should be avoided. Multicollinearity in the data can be assessed using the statistical criteria like correlational metrics, tolerance, where T or tolerance equal to 1 minus R square and T should be less than 0.01, then it indicates multicollinearity. The other assessment is by variance inflation factor, which we refer to as VIF, and VIF is equal to 1 upon T, and VIF should always be more than 100, then it confirms multicollinearity. That is, we must have a VIF factor of less than 100 to avoid multicollinearity in the data. And another method can be the condition index. Multicollinearity can be corrected using relevant methods that we shall explore in the subsequent modules, and the readers may refer to the module on multivariate methods introduction. Another assumption is of autocorrection. The residuals should be independent of each other. That is the assumption that any data that is to be exposed to regression analysis need to take care of. Practical applications of regression analysis. There are a number of techniques available for carrying out a regression analysis. Some of the methods are known to the readers like linear regression analysis. In linear regression, the linear regression function has a finite number of estimated parameters. It is parametric. There are non-parametric regression techniques also, where the regression function lie in the specified set of functions that can be infinite dimensional. Developing a regression model. Let us take up an example to demonstrate the simple regression analysis using two variables. A researcher wants to know about the helmet wearing behavior on the basis of the data obtained on socio-economic status. The school students are chosen sample and the independent variable is the percentage of children receiving reduced fee school lunches in a particular neighborhood as a substitute for neighborhood socio-economic status. So, the socio-economic status is being measured with the number of reduced fee school lunches that the students are getting. The dependent variable is the percentage of bicycle riders wearing helmets. The researcher finds a strong negative correlation of -0.85 between the two chosen variables. The scatter plot of the obtained data is shown in figure. A straight line of best fit can be fitted to the data using the least square criteria, and the line of best fit enables the statistician to develop the regression model. Figure shows the scatter plot for the data showing school lunches and helmet wearing behavior. A line of best fit is described as a straight line that runs through the data in such a manner that the sum of squares of the deviances from the mean is minimum. Let us understand this concept. A line is recognized by its slope or the angle of the line describing the change in y per unit of x, and intercept is the line crosses the y axis. The regression describes the relation between x and y scores with just such a line, where y dash is the predicted value of y, a is the intercept of the best fitting line, and b is the slope of the line. Hence, the regression line becomes y dash is equal to a plus bx. Now, identifying the best line for the data becomes a question. Had all the data points fell on the single line, identification of the slope and intercept would have been easier. But since the statistical data has random scatter, identifying a good line becomes a process requiring efforts. The random scatter around the line is recognized as the distance of each point from the predicted line, and these distances are referred to as the residuals. One can see this in the figure. One's aim now is to identify the line that minimizes the sum of squared residuals, which is called the least square line. The slope of the least squared lines is represented by the formula b is equal to SSXY upon SSXX, where SSXY is the sum of the cross products for variables x and y, SSXX is the sum of squares for the variable x. In the above example, we shall take the liberty of presenting the data as SSXY is equal to 4231.13333 and SSX as 7855.67. So, the b or the slope becomes as -0.539. The intercept of the least squared lines is represented by the equation a is equal to y bar minus bx bar, where y bar is the average value of y, b is the slope and x bar is the average value of x. In the example, again we have the values available to us. Y bar is taken as 30.8833 and x bar as 30.8333. So, a becomes, on substituting the values in the equation, as 47.49, and on substituting the values of b and a, the regression model becomes y dash is equal to 47.49 plus minus 0.54 into x. Now, making the interpretations, we find the figure and find the regression line here. The slope in the regression model is the average change in y per unit x. Thus, the slope of minus 0.54 predicts 0.54 fewer helmet users per 100 bicycle riders for each additional percentage of children receiving reduced fee meals. Since the regression model can be used to predict the value of y at a given level of x, like the neighborhood in which half the children receive reduced fee lunch, that is x equal to 50, has an expected helmet use rate per 100 riders as 47.49 plus minus 0.54 into 50, because we know the value of x is 50 here. We substituted it in the regression equation and we find the predicted value of y as 20.5. So, this is how we can make practical use of the regression equation and apply the concept of regression analysis to study the two variables and on understanding their relationship predict one upon the basis of the other. Factors affecting regression analysis. The number of cases. When doing regression, the cases to independent variable ratio should be 20:1. That is 20 cases for every independent variable in the model. The lowest ratio could be 5:1, that is 5 cases for every independent variable in the model. Accuracy of data. One should check the accuracy of the data entry to ensure that all the values for each variable are correct. Missing data. One should look for missing data, and if there are a lot of missing values, one should not include those values in the analysis or delete the cases if there are few cases with missing values, or if it is important, place the mean values of that variable in the missing places. Outliers. One should check the data for outliers, that is, in an extreme value on a particular item, an item which is at least 3 standard deviations above or below the mean, one may delete those cases. If they are not part of the same population, or retain it but reduce how extreme it is, that is, recode the value. Using SPSS for regression analysis. The Pearson's product moment correlation is a popular statistical method to assess the basic statistic in regression analysis. There are 3 types of regression analysis: standard or simultaneous regression analysis, sequential or hierarchical regression analysis, and statistical or stepwise regression analysis. The standard or simple regression analysis is also referred to as simultaneous regression analysis, in which all predictor variables are entered in the regression equation simultaneously. Each predictor variables is evaluated in terms of what it adds uniquely to the prediction of the criteria variable. Simple regression analysis is used in exploratory and hypothesis building regression models, although it is a much less used approach in quantitative research. Regression analysis, SPSS, IBM SPSS 20 commands. The source of this problem that we have taken and the commands are from W.E. Martin and K.D. Bridmon 2012 Quantitative and Statistical Research Methods from Hypothesis to Results, which is published by Josie and Bass, a Wiley imprint, San Francisco. Let us take an example. A researcher wants to study whether the doctoral students' lower interest in scientist activities are more highly predict higher dissertation stress than do their interest in practitioners' activities. The scientist and practitioner scale of the SPI are predictor variables, and the higher score reflects higher interest. The dependent variable in the study is the dissertation stress inventory that we are going to refer to as DSI, and higher scores on DSI translate to higher dissertation stress perceived by the sample of doctoral students. Bivariate correlation coefficient, multiple correlation coefficients, and sequential regression analysis will be conducted at alpha equal to 0.05. The commands that can be given are: open SPSS data file called MRA data and click on analyze, go to regression, then to linear. Click over DSI, that is dissertation stress inventory scores, under dependent. Under independent, click over SPS scientist, then click on the next button to the upper right. The SPS sign disappears and the program stores the first predictor variable. Click over SPI Pract and click on the next button. You have set the model you want to test. Click on Statistics button, check on Estimates, Confidence Interval and type a 95 besides the level percentage. Check on Model Fit, R-squared change, descriptives, part and partial correlations and collinearity diagnostics and click on Continue. Click on Plots button and click over Z residue to the Y box and Z grid to the X under standardized residual plots. Click on histogram and normal probability plot and click Continue. Click on the Save button, go to Distances, click Mahalanobis and click Continue and click OK. Save the results. Summary: the concept of regression is a step forward in the direction of studying relationship among the variables statistically and using it to the advantage of predicting the other. The straight line of best fit can be fitted to the data using the least square criteria. The line of best fit enables the statistician to develop the regression model. A line is recognized by its slope and the angle of line describing the change in y per unit x and interceptors where the line crosses the y axis. The regression describes the relationship between x and y with just such a line. Factors affecting regression include outliers, missing data, number of cases, and the assumptions for regression are multicollinearity and singularity or variables related, homoscedasticity, linearity and normality. The steps involved in using SPSS 20 for regression analysis are also discussed in the text.